Okay, the problem is find the index of a fast occurrence of a string. Two strings are given, needle and haystack. You have to return the index of the fast occurrence of needle in the haystack. So if it is not present, return -1. So that is the case. So in here I will say haystack as text and needle I will say as target. Okay, let's start. Let's see the constant. Constant is haystack or text length is 10 to the power 4. Needle length is also 10 to the power 4. So fine. So let's start. In this. Let's say this is our text. This is our target. If we apply for our generic uh, brute force or naive approach, what is our case? So our I and j we should start here. So if both an I and j are same, then I will increment I and j. Similarly, I do that every time I do this. I and this becomes j, and this point you can see I and j are not equal. So whenever it becomes not equal, I will be going to be repointed. I will be reinitialized with the previous I value, previous initial the value we have to which I am going initialized with I plus 1. So I is going earlier it was I initialized I with the 0th index. Now I will initialize I with the first index, and this will be empty. Okay. Similarly, j again, if characters are not placed same in the I and jth index, j will be initialized as 0th index. Again, I have to compare. You see, b and a are not equal, so simply I will initialize I. Whenever not equal, I'll initialize I to the next index, and j will be the again starting with the 0. Okay. Now again, I will do the brute force approach. I and j are equal. Ith character and jth character are equal. So that time I will repointing every time. Okay. So here again it is becomes a, again it is not equal. So I right now I will initialize at this place, and j will be going to the very fast place. Okay. So this is how our brute force approach works, right? Okay, let me finish that way. Here also I is not going to be matching, so I will initialize this place. Now see here, letting point another character here a, and let's point 9. So what happens here, like simply I and j are same, so I will be increased, j will be also increased, ith character j character all again same, so they will be increased, again increased, ith character, sorry, this will be jth character. So just a minute, let me start from the beginning. So I will be initialized at this place, this I, and j will be here, both are same. So I this place, j becomes this place, again both characters are same. I this place, j this place, again both characters are same. I this place, j this place, and right now I come in this place and j come this place, both are same. I come this place, j going to out of index, or you can say whenever j goes to out of index, it means it is j will be the length of the target. So whenever j becomes the length of the target, it means like our target has been achieved. We find our target string in my text string, and we can return the corresponding index position. So what is the index position? What is the index? Notice what is the index position of I right now is 9, right? What is the index position of j right now? It is 5. Okay. So even the 5 is out of index, but still j currently is showing 5. So if I minus this thing, you will get 4. So here my target string started at this 4 index. This 4 index. See? Up to this index to this place, uh, my target string present. Correct? So this is how we do in the brute force approach. Okay. So what is the disadvantage of our brute force approach? See, disadvantage of brute force approach is, see, whenever, let's say I start at this point, correct? I start at this point. Some amount of time I goes to this place. Some amount of time I point this place. This is current now I. So same time j start from this place, and some amount of time j point to this place. This is my j. Okay. So whenever I and j is mismatching, okay, that time I going to be repointed, I going to be reinitialized at this index, and j I am going to be reinitialized. This 0th index again, correct? So this is the waste of time. Why I am saying waste of time? See this one. When I reach at this index 4, and j also reach at index 4, that means what? This 0 to 3rd index are matching in both cases. Okay. So that's why it's matching. That's why both of I and j both point to the 4th index, isn't it? So now the question is, what happens? Like, see, in the same the string that is actually same both of the cases. Now I am checking that only the same string. What is the string that is present in the both of the cases? AB and AB. Okay. So now see, there is a pattern actually in both AB. This AB actually same. So if AB both AB present in the target string, that means this single AB that also must be present in the target string, because see, this is the common. This is the thing. This AB is matching with AB. This AB is matching with AB. So if AB is common, sorry. If AB is common, then single AB must be present in the target string. So no need to recheck the single AB, because I know like single AB is already there. So no need to recheck my that AB again, recheck my pattern if it is same or not. So simply I can do what, I can point my J pointer at this point and making my I pointer the same place. So what is the advantage of that? So this AB is and this AB is not going to be rechecked, recompared. So that is, it is saving the time. So how would we do this? I will come this thing later, but understand the point. So this, so no, so this AB no need to be rechecked. So right now my J will be here. Now I can check again AB and AB. So let's start our algorithm again. So again I is same. I come to this place and J come to this place. Both are same. Again I come to this place and J come to this place. Fine. So again this is mismatch. Whenever the mismatch again happen, I will do what? What is the entire string that is matching right now again? That is nothing but AB. So again the entire string that is matching, that AB, I is right now this place, so this AB is matched. Okay. So again what is common, this AB? Obviously again AB is common in this string, this AB is common. So both this AB is already present. So this here, so this AB is also present. So no need to check again AB. I can again repoint my J at this index, at the second index, so that this AB part and this AB part are somehow compared. Without comparing, I know as AB is present in my string, this AB must be also present. So that's why this AB and this AB are compared. No need to compare it again. Okay, so how we are getting, how could we get this comparison, like it is present or not? Okay, so this is the one of the approach. So this approach actually invented by three computer scientists named as KMP. If I'm not wrong, the name is Knut, Morris, Pratt. So these three guys actually invented this approach, and from their name, the algorithm names as a KMP algorithm. So let's know about this KMP algorithm. So in the KMP algorithm, actually what we are doing right now, actually, we are actually doing whatever the string is matched, I am finding the pattern in this string. So what is the string or match? That is nothing but AB and AB. What are the pattern? Pattern in the sense, actually I am checking what is the maximum prefix and maximum suffix are common. So what are the prefixes are in these cases? Prefixes are A can be one prefix, AB a prefix, AB A is a prefix. What is the suffix of this case? Suffix is a B, AB and BAB. Entire string is not a prefix or suffix in this case. So I have to I cannot consider entire string as a prefix or suffix. Okay, so this AB and AB are same. So what are the common prefix or suffix? This, see here, this A is matching this A, and this for this A is not matching with anything, right? But this AB is matching with this AB. So for here, only common prefix and suffix is AB and AB with the length of 2. Fine. So instead of this example, take another example. Take another example. Let's take another example. Let's say A, B, A, B, A. This is the case. So what are the prefix and suffix in both cases? Prefixes are A, A, B, A. Sorry, A, B, then A, B, A, then A, B, A, B. What are the suffixes? Suffixes are A, B, A, B, A, and B, A, B, A. These are the prefixes, these are the suffixes. What is the common in between those two? See, this A and A is common, so length is 1. But see here, this ABA and ABA is also common, is a length 3. So what is the longest common prefix and suffix of length 3? So this is nothing but this ABA I'm considering as a prefix, and this ABA considered is also a prefix, sorry, suffix. So this A is a common in both cases. So that's why it's a prefix, longest prefix and suffix. So whenever, so see here, what is the advantage of finding longest prefix and suffix? So what is the advantage of doing that? Advantage of doing that is, if I know like this ABA is also present here, so no need to check ABA again. I can directly start from BA because I know this ABA is already present. So here, that's why I have taken this example. The example was ABAB, right? So ABAB, that is the case, and our target string was ABABC. So if it is AB and AB is both string, so both string, if it is common, both string is common, and in this common string, this AB is also common. So what I can do, currently I point to in this place, something is there, some character is there. So why I need to check this? Why I need to check this AB? This is a kind of redundant checking, right? So I know this AB is common, and this common string, sorry, I know this ABAB is common. In the common string, this AB is common, correct? This AB is common. So do I need to check again this AB? No need to check now. So we can directly, I know like this part, so as that is a common suffix as well and common prefix. So this part is going to be anyhow going to be common. So I can start my target checking my J point to here, and again whatever the character present in these places, I can simply compare. Okay, so I can simply compare to these places, correct? So this is how we should work. Okay, so let's find out some example. Let's see some of the example how to calculate our longest prefix and longest suffix. Then we can solve the KMP later. So let's take some examples. So these are the examples. So initially my fast string. So whenever I am checking the longest string prefix suffix in a particular way, if I am ith place, so I have to check longest prefix and suffix from 0 to ith index. Both are including in this index what is the longest prefix and longest suffix. Okay, so by default my fast I have to store this answer, this longest prefix and suffix in a array, you can say. So you can say is naming as some, so say usually named as LPS, longest prefix and suffix. It is an array. Initially everything is 0 or empty, you can say. Okay, so initially my first index, ith index will point this place. This is my ith index. So in this ith index, what is this? What is the LPS of ith index? What is meaning of LPS of I? LPS of I, what is meaning of that? It is meaning longest, or LPS of, not the longest, length of longest prefix and suffix between 0 to ith index, both inclusive, both inclusive. Okay, so this is my LPS of I mains. Okay, so what is this in the case? So first of all, my first I will be 0th index. So 0 will always, this is the first character. So the character or string itself is not its prefix or suffix in this case. Sometimes we consider entire string is considered as a prefix or entire string considered its own suffix, but here it will not be considered. So A is not considered as a prefix or suffix. So what I will do, for every time LPS of 0 will be 0. Every time LPS of 0 will be 0. Fine. So right now I come to this place. I come to this place. Is there any from the B in this place, Bth place? Is there anything common? Is there anything common with the previous one? Like what as the prefix and suffix could be? A could be the prefix and B could be the suffix. Any common? No common, right? So B will 0. So then I come to the second index. Whenever I come to the second index, what is the string becomes A, B, A. What are the prefixes are A, AB. Suffixes are A and BA. These are the suffix. What is the common? Actually, you can see A is common. So this A is common with this A. So that's why this place will become, what is the longest place? This A becomes 1. Okay, fine. Then I go to the third index. Third index, what will becomes A, B, A, B. What are the prefixes as I told you earlier? A, B, and A, B, A. Suffixes are B, A, B, and B, A, B. What are the longest common prefixes and suffixes? This A, B, and this A, B. Correct? Okay. So, what is the case? This is nothing but 2. Fine. Okay. So, let's take another case. Another case means I goes to the next case. I goes to this place. Okay. So, longest. Let me put this thing in some other places. Let me put it here right now. Okay, so let's see what is the I becomes 4. I becomes 4. String becomes A, B, A, B, D. What are the prefixes? A, B, A, B, A, B, A, B. This is the longest one. What is the suffixes? D, B, D, A, B, D, and B, A, B, D. Is there anything common in this longest prefix or suffix? Nothing is common, right? So nothing is common, that means it becomes 0. So this is my LPS array, longest prefix and suffix. Okay, so I'll show you a pattern after some time. So for right now, take another example. So here, let's see in this example, I becomes 0. So as I told you, by default LPS or LPS is nothing but one empty array. So my 0th index will be start with 0. Okay, so I always start I from this place 1. So see here, this whenever I becomes 1, string becomes A. What is the longest common prefix and suffix? A, and A is the long prefix and suffix is A. A could not be because it is a whole character. So there is a one common, that is whole. So it is 1. Next I becomes in this place. So B is added. What is the longest prefix and suffix? A, and here will be B. Here it will be B and A. B and AB. B and AB. This is the longest prefix and longest suffix, that is common. Fine. Okay. So in this case, this is a common. So what is the common longest common suffix and prefix? Nothing is common actually. So it will become 0. Fine. This goes to this place. Third index. String becomes this. What is the longest? What are the prefixes are A, B. A, B. What is the suffixes are? It will be A, B, A, and A, B, A. Anything common? Yes, it is common. This is nothing but this one. This one is common. This A are common. Okay. So max it goes to 1. So right now, what is the next I becomes this place. What is the longest prefixes are a, this one, and this is going to be added. Okay, and suffixes, this is going to be added. Okay, so what is the common? You can see two are common. A is also common, a also common. What is the longest among them? A is longest. So common will be this one. Two. Fine. Okay. Let's see our next example. Next example is this one. So next I becomes to the another place. It becomes to point to B. So B will be added. Prefixes are, these are the prefixes. Okay, and this will be the prefixes, suffixes. Sorry. So what are the common in this case? If you notice, this AAB is the common one. AAB is the common one. Length is 3. So that's why length becomes 3. And next again, this one goes to A. So one A will be added. So prefixes are A, B, A, B, A. Suffixes are A, B, A. And these are the suffixes. So what are the common prefix and suffix if you notice? So nothing is nothing but this A, B, A of length 4. Two are common, single A are common, but longest are A, B, A. So this becomes 4. This is our LPS of this string. So now you notice a pattern. How could we calculate? How could we calculate this longest prefix and longest suffix? Is there any way we can calculate? See here, whenever I am calculating this ith index or something, whenever I am calculating this ith index, I will check, is there anything, I will check, is there, what is the length of current maximum, like a current longest prefix and current longest suffix, what is the maximum of that? Okay. So what is we are getting? So here, see this, in this place, whenever I is point this place, what is the longest common, uh, longest suffix at this time? At this time, longest common suffix is 0. So this time, this length is actually pointing to the index. See here, this A actually pointing to this which place? This A, B, and A, B. So okay, let me give you again another example. So let's say my current length is 0. This length is nothing but my longest common prefix or suffix at the current moment, at this current moment of time. Okay, so let's recalculate it. By default it is 0. I know, you know that. So I will start here. What is the longest prefix item? 0. So what is the length is 0? That means no longest common prefix and suffix is same. So I will compare with the first index as nothing but 0th index. So that's why I compare the length, target of length, because 0 is common, nothing is common. So whenever nothing is common currently, then so I have to check from the first index. First is here. So A, B, A, B, A. If right now I'm comparing this one, I should compare this one with this one. Okay. So then this one with this one, then this one to itself, right? To get the common prefix or suffix. Or if we have to compare this part, only this part, how could I compare this only this part? I can compare this one with this one if it's common. So then I can compare this one with this B, both are common. Then I can compare this B with this B. So this is, we can find it out for an, okay, let's give you an example for, like, if you do the diagram, then it will be understand, it will be easy. So first of all, this is the 0 and this is the length is 0. Length is saying, let's say, current longest prefix or suffix. That is nothing but right now at the I, when I is 1, current longest prefix suffix is 0. That means no common prefix suffix. I is pointing 1. That means I am going to calculate for this place. Going to calculate for this place. Okay. So that means I am going to check only these two cases, and in these two cases nothing is common. Correct. Nothing is common. So what I can say, like I can compare this B with this length index, say in the same index what is present. So at this index what is present is A, but that is not common. So I will check if my target of my length is equals to target of my I. I am checking this. If it is the case, then I will do something. Let's see here. Length is not common. So in the zeroth index, length is 0. So that 0 means I will check the zeroth index. Why I am taking this length, you will understand in a minute. So this is right now. If it is not common, else I will increase this, put as 0. Else, what is the else case? So there are two cases will be there. So let me write it down. This is the definition of LPS. So let me say, so if I am checking if my target of this length is equals to target of my current index I. If it is the case, I will do something. Else, if it is not the case, then I will do something. So if it is the case, then I will do what? I will do for now. If it is right now, it is not matching. So else I will do. I will increase, put this, that LPS of, I'll put this LPS of I. If it is not same, I'll put as 0. Put as 0 right now. For right now, I'm doing that, and I will put this length, and or I will be incremented plus 1, I plus plus. So I'll coming to this place. Fine. Okay. So right now, what should I do? So right now, it will putting 0 and I is there. So right now, I is what? A. So see, this LPS of currently length is 0. So target of length is nothing but this A, and target of I is nothing but this I. So again, why we are checking target of length, you will understand right now. Next case, you will get it. So for now, just check one. So both are same. This one is same. Okay. So if both are same, then these are. Then I should do what? If target and both are same. See, they now at this moment in this area, I got longest prefix and suffix is length of 1, because see, this is the longest prefix and longest suffix. So I am got length of 1. If it is same, length will be incremented and it will be also 1. So if it is same, length will be incremented, and in that LPS of I will put this current length, and I will increase I plus plus. Okay. So right now I becomes in this place. So I becomes this place. So what will happen? So I become this place. So current is 1. So longest, right now I get at the longest one. So before this I, what is the current I is there? Before this I, what is the longest prefix and longest suffix of length 1? So length 1, longest prefix and longest suffix with the length 1 means what? Means this is the first string is matching. So I am not checking any subset of it. I am checking a subset of the including the first case, because whenever we check the longest prefix, we always have to include some of the character from the starting from index 0 to up to n minus 1, before n minus 1 of that. Okay, so that's the reason we are checking with the 1 is there. So I will directly check this B with this 1th index, first index. So why I am checking the first index? See here. So this up before this I, this pattern, in this pattern, longest prefix is 1. So obviously my current assumption will be my first string is matching, this string also may match. So why should I check this A and this A again? I know na, before this thing, this A and this A is matching. I know that. Now I will only check if this B and this B is also matching or not. If it is matching, then what should I say? What should I say? So if this B and this B are matching, then I will get length of 2, because from 0 to this ith part, this up to this substring, this AB is the longest common prefix and suffix. Correct. So I will check this B with this first index. That's why I am checking length, target of length. Length is nothing but storing up to which the index is match. 0 is match means before that 0 that is match. Before the 0 it is match. So length right now will match like from which index I need to compare. So before which index it is match. You can say length is kind of it is also storing the length of the substring, so the length of the substring, and also storing for which index I should start comparing. See here, length is 1, so that's why 0 index is done. So length is nothing but it is storing length, not an index. So length is 1, that means up to which index it is matching, length minus 1, so 0 to index. So from which index I should start checking? Length index, 1 index, first index. Hope you are getting it. So that's the reason I am comparing target of length. Because see, again I am saying this one. Why target of length? Length is right now storing what is the length of longest common prefix suffix in the current index position I. Current index position I means 0 to this before this ith index. This is what length storing. 0 to before this ith index, what is the longest common prefix and suffix. If length is 1, that means one string is matching. One string is matching means what? That is nothing but 0 string. Correct. 0 string is matching. So then now what could be my next case? Next case, this could match with this string, or it couldn't match this string. Two possibilities are there. It could match or it couldn't match. So I will check this current index I with the current target of length of 1. Because see, it is confusing, I know. This is 0 based indexing and length is 1 based indexing. That is, it is little bit confused. Like whenever length is 1, that means up to this, before this one, my string is matching. So that is nothing but 0. If it is 1, so if length becomes 2, that means what? That two strings are matching. Two characters are matching. Specific, two characters are matching. Two characters are matching means that is nothing but 0 and 1, obviously, because they should match the prefix, and prefix should start with the 0th index. So 0 and 1 matching. So length is 2. So that means my second index, if another match, the second index is also the match, then length becomes 3. That's why I'm checking always my target with the length, target of length. Hope you got it. Okay, so right now what is I is currently on the third index B. So right now I will check target of length is what? 1. So this one I will check. So this one I will check. 1 is it is equals to I. Yes, it is equals to a character, both are same. It is what? Length plus it becomes 2, and length becomes 2. LPS of I becomes not I. Here I did a mistake. It is not I. This becomes the length. This is length. So it becomes length, and I plus I becomes here. Now again, what is my length? Length is 2, right? Length is 2. So again I will check this case. If target of length, that is nothing but A, and target of I, it is matching. No, it is not matching. So if it is not matching, I will put LPS I equals to 0 at I plus plus. So for now, this algorithm seems correct for right now only. We'll see what happens next, but for right now, it is correct only. So it is fine for right now. Okay, so it will be incremented and it becomes 0, and I go to out of it. This is how we can calculate our LPS. Okay, see, this algorithm works for not this case. So let's put it here. We know this is the case. Let's compute it. I starting from 0. 0 is almost 0. So I always start from first index. The first index length is what? Length is 0. So is it matching? Length, what is the target of I? target of I is 1, and target of length, nothing is matching. So it will start from the 0 index. Nothing matching means length is 0, nothing is matched. So it should match from this length index. That's why. So that's why it is a, our length is nothing but the size of the longest common prefix and suffix, and this index is should be the 1 minus length minus 1. Okay, so that's why we are checking the length index directly. So if it is confusing, you can consider index IDX as a index, but for me it seems like length is much more easier to understand. So because the length is 1, so from this first index I can start computing. You can use indexing as well. It's your choice. So for now my length is 1. So it is matching with the 0th length, which is fine. So length becomes what? Length becomes 1, and LPS of I, LPS of 1 becomes 1. Fine. Then I plus plus. This one y. So length becomes 1. So it will checking the second index with the this first index, and B not matching. Okay, not matching in sales case. LPS goes to 0. LPS goes to 0, and I plus plus, and I will put LPS of equal to 0, and also I have to do one thing here. Also I have to put another way, like right now it is fine. Length is still what? Length becomes what? So length becomes 1 only, and LPS I put as 0, I plus plus. Now this one, now see this I should do check with what? This I should check with this one, right? So if I check right now, my I length 1 is pointing this index, right? So right now this condition satisfies, but is it the correct case? Then it becomes, if this condition satisfies, length becomes plus plus. So length becomes plus 2, and it becomes what? If length becomes plus 2, then length, like if I do this algorithm, it becomes plus 2 and it shows 2. But see this thing, only this character, what is the longest common prefix of, we know it is 1. So we cannot simply write LPS equals to 0. If it is matching, we cannot increase the case. Whenever I got mismatch here, I have to put length also should be initialized with the 0th index. For right now, for it seems it's working. For this index, it should be re-initialized with the 0th index, correct? So is it the correct approach? So let's see. If I do this thing, length is initialized with the 0th index. So what happens after this I? Whenever this B mismatch happens, this one goes to 0. I becomes this in place, and that's all. And this case, it will again compare with this I. And so length of 0. See, from because it is mismatch, right? From here it is mismatch. So up to this there is no longest common prefix or suffix up to this case. So whenever I consider this A, so then this A should compare with this one. Current length from up to this I, what is the current length? Length becomes 0 because no longest common prefix suffix for this up to this character, no longest common prefix and suffix. Like there is no prefix or something that is common. So that's why the length is always storing what is the current longest common size, of longest common prefix and suffix. Okay, so that's why it becomes 0. Okay, so fine, it becomes 0. So this A will right now compare this 0th index. So it is common. So length will again increase by 1. It will be our LPS. So okay, so LPS length becomes 1. So it becomes 1 LPS, and I will be increased. Okay, so here what is I? I is nothing but ith character is A, and longest length character is 1. So first character is also A. So again match. So length becomes 2. It also becomes 2, and I will be increased. Again it is same. So same in the sense because current target I is B, and length of this length index target is B also. Again it is same. So that's why it is increased 3 and 3. And at the end again for I comes here, and it is also again same, so it becomes 4, and it is also 4, and I becomes out of index. So right now it looks cool, good for right now. Okay, so okay, let me, I guess it is not required, so let it do it later. So again, let's say take this example. Let's say, is my algorithm still correct or not? So actually it is not correct, I know. So let's give you the example why it is not correct. Otherwise you will not understand. Let's say cut. Okay. Let's put this example here. So actually what I am doing actually, so if I write the entire case, if I write my entire case, it looks like this. So my algorithm is starting. I am initializing one array. Let's say aim equals to target dot length. This is my, let's say, target. After that I initialize one LPS array. So LPS array is nothing but of array of size in, array of integer, okay, of size in, sorry, m, size m, and initialize everything is 0. By default it is 0. And after that, as I told you, like I will initialize this LPS of 0 is 0, even though it's a kind of redundant state. So LPS of 0 is 0 because I have initialized everything as 0. So it is a redundant state, you can think of it. And then what I am doing, I am indexing I equals to starting with 0 and writing a while loop while I is less than m, I will iterate. After this I will iterate and I will check. After this I will iterate, and that's all I will do. Fine. So this is our algorithm right now. We are checking. So let's do the algorithm again. Okay, let's do the algorithm again. Okay, so before that I did a small mistake here. That is, not only I have to initialize length I, also initialize length as well. So length equals to 0 and both I equals to 0. So let's see, let's do our algorithm. Let's see is my algorithm is correct or not. So LPS of 0th index is by default 0, as I told earlier, is 0. So my current now my length is 0, and this is my ith index. This is my ith index, right? One index I. So I index is, this is nothing but I. So in the ith index, what is the length? Length is 0. What is is it same? Ith index character is A, and this character is also A. So both are same. So whenever both are same, then I will do length plus 1. The same length I will put here, and I will increment this one, right? So LPS 0, it was 0 earlier, increment by 1, this will be I. So I will be, right now I was here, I will point to this place. Whenever I goes to this place, so here what is the length is 1. So it will compare the fast index. When the length is 1, it will compare with the fast index. So it will compare and fast index, and this one is becomes false. This is not true. So whenever not true, I am doing what? I am simply putting length equals to 0 and LPS of I equals to 0 and I plus plus. I am doing that. So in this case, what I am doing? So this one I am doing length becomes 0. Put the same thing is here and I plus plus. So I will come this place. So I'll add now third index. So length is 0. So it will check the 0th index. So 0th index and this one will check. Yes, both are same. So whenever both are same, I will increment length. Same I will put here. Where I'm, so I'll put it here 1, and I will increment by I. Fine. When this place also same, because length is 1, so first index it is present, first index only 1 is present, and in this index also 1 is present, so length will be incremented by 2, and this will be also we have to put 2 in this place. Okay, fine, and increment the I. See here, what is the length? It is the length is b, and what is the length is b, so it is same? No, it is not same. Okay, if it is not same, so what will be the case? It is a length becomes 0, and LPS becomes 0, and I plus plus, I will come this place. But my question is this one is correct? See, why I am saying this? Let's take the example. A, B, A, A, B, A. What is the prefixes of entire string? A, B, A, and A. This is a prefixes. Suffixes are A, A, B, and A. So, see here, longest common, if you see I am putting, whenever it is not matching, I am putting simply as 0. Is it a correct approach of putting exactly 0? No, because here, it is like visually one string is common, by say like this A is common. Even though it's 2A are common, these 2A's are common. So even if it is not matching with this length, this current length index, when I am checking this length, whenever it is not matching, I am simply putting at the length of 0. Okay. So why I can simply put it is not matching with the this length 2 is matching. Okay. So up to 2 length is matching. Okay, length 2 is matching. Up to this and this one is matching. So up to this case, whenever I considering this case, I am considering this and this, considering what this string will match with this string, but it is not guaranteed. Like this string doesn't guarantee, like it is a must, not a must follow rule, right? This string, I am considering this string will match up this string, but it is not guaranteed. But in the entire string, this string with may compare to this string now. So this could be common. This one and this one could be the common case, right? So what is the thing I am doing wrong? I am doing wrong whenever it is mismatching. I am simply putting length equals to 0. So instead of putting length equals to 0, I will do what? I will check what is the case of the previous one. Okay, so what I will do here, so in this case you can clearly see, like we cannot simply do that, we cannot simply do that length, like this step we cannot simply do it. We cannot simply do this. So what we have to do in this time, so in this case we have to check, like I was checking this part, right? So up to this one places are matching. These places are matching. So in the previous case, so checking this index. So in this index, this place and this place are matching. So when I am taking the entire range, what we are checking in this entire range, we are checking this place with this place. Okay. So want to see this match or not. So that's why we are checking this one and this one. So that is not the correct one. So if it is not matching, that time I shouldn't check this one. I should check with this one. So how could I get that one? So that's why we have to write another thing, that length I have to update by. So we can previous length. So whatever we are checking, so that previous length. So it will be LPS of length minus 1, previous length. What is the index position of this LPS of length minus 1? Currently my LPS for what? At this moment, whenever my I at this last index, so my LPS length was 2. So I cannot check the second length, I cannot check it directly second length. So I have to go to the before that length. What is that before that length, what is that length storing there? It is storing 1 first index. So index number 1. So I can check that with the index number 1. Okay, so I have to do and check with index number 1. So we will go, instead of go to directly putting as 0, we will put as 1, 1, and we will put at 1 length minus 1. So here currently my length was 2 minus 1, nothing but 1. And what is the, in that place, what are the length is mentioned in this index? That length I have to take. So that length is nothing but LPS of 1 is also 1. So then I have to take 1. If LPS of 1 is pointing to 0, if think it is pointing at 0, then I should take at the 0th index, the index it is pointing to. So length will be upgraded. We cannot directly do LPS of length minus 1. We have to do LPS of length. Cannot do length equals to length minus 1. We have to do length of LPS of length minus 1. Why LPS of length minus 1? I have to check the whenever the previous index last length was matching. Currently length was matching length 2. Whenever length 1 is matching, so in that case, which index is present, I have to compare with that index. It is 1 index is present, so I have to compare with the first index. Length will be 1 right now. Okay, fine. So this is what we have to do. So we have to update this else condition. Else condition we have to update. So else condition. So there is also another problem is there. Length minus 1. So if length is itself 0, if length is 0 itself, so minus 1 is invalid case, right? So you have to write another case. If length is not equals to 0, that time my length will be updated by length equals to LPS of length LPS of length minus 1. Okay, LPS of length minus 1. That's all. So if that is not the case, if length is 0, that means else condition. If length is itself 0, so that time we can't do anything. We can't do anything. We will simply put that as a previous case, that LPS of I equals to 0 and I plus plus. That we have to do in this case. This is the whole algorithm. This is my entire algorithm. So let me rewrite the algorithm and solve the problem. Like one final problem, let's solve this one. Okay, let me pause the video and rewrite the algorithm. So this algorithm is just for construct the LPS. Let's say function construct our LPS array. Construct LPS. What is given LPS? We are like longest prefix suffix array we create for the target. So target is given, we do the construct, and at the end we are going to return LPS array. So this is not actually your KMP. This is the one part of KMP. So return our LPS. Return the LPS array. Okay, fine. So let's do our LPS array. So I is starting with the 1. So by default, this is if I do the LPS of 0 is 0. I is starting with this index I. Length is starting with 0. So first we will do check what length is equals to target of I. It is target? No. If it is not target, then we will check what if length not equals to 0. But here length equals to 0. So what we will do? We will LPS of I equals to 0. We will put this LPS of I equals to 0, and I will be incremented by 1. I will count this place. So what will here? It will here, you can see length equals to 0. So target of length, this index is equals to target of I. But this is this index. So both are same. If both are same, we will simply increment our length. Put this thing inside our LPS. In our LPS, let me write LPS in the register. So LPS is 0, 0, 1, and after that increment the I. Okay, fine. I goes to B, this index I here. So after that it is B. So what will be there? It will check again that length is equals to target. Length is 1. So this is 1. This is equal to the target. So if it is true, then length will be increased. Length will be increased by 1, and that same thing will be put it here. Fine. So I will now increase it again. So again length is 2. So second index it is same. So length will be again increased by 1. So length becomes 3, and I becomes in this place. So I becomes this place. Okay, okay. Also I forgot to update LPS. LPS also 3. Okay, at this I position, what is the length index? 3. So what is the here? It is what? See, so both are not same. If it is not same, length is not 0. So length I have to update. Length will be decrement by 1. It becomes decrement by 1. So I shouldn't put this. So length will be decrement by 1 by 2, and same the in the LPS error what is mentioned there. I will check with that. So why I am check with that? See here. See, right now it will be clear. So if I do length minus 1, length minus 1 is what? Length minus 1 is nothing but uh, length is 3 and minus 1 is 2. So 2 I will check, 2 will check with 1. But here I check what? I should have checked length becomes 1. So I have checked should have B. See why I am check. See, so because this A is matching this A only. This A is not matching. This A should match this one. So I am checking for length of 2. So whenever I am checking length of 2, that time I checked length of 2. So for see here, earlier my length is 3. So sorry, not earlier. Right now, before checking this one, my longest common prefix is 3. So okay, so I am checking for the fourth index. So if it is right now, it is match again the third index, then length will becomes 4. But it is not matching. It is not matching. So I have to check with the length. So I have to check whether it is matching with the length of 2 or not. Length of 2 or not, I have to check it is matching or not. So to check length of 2, what should I check? It is length of 2. So I should have checked length of 1. So okay, so first index I have to check. If this one and this one match, then it will be length of 2. Why length of 2? Because this A and this A is always match. So compared to that, this should be length of 2. So that's why I should the index position 1. How could I get index position 1? See, this index position 1 is mentioned here. This is nothing but LPS of length of 1, length minus 1. So that's why I do this kind of step, that length equals to LPS of length minus 1. So the current length is 3, length minus 1. So length minus 1 becomes 2. So LPS of 2, it will give us from where, from which index I am getting my length equals to that time 1. So length equals to 1, which position at the index number 1. When I was index number 1, that time my previous index is matching. Length, this one is matching. You can see this one is matching. So right now I'll check whether this one is matching or not. So this one is not matching again. So what is happening? Length becomes updated. So length will become updated by 1. Why 1? Because LPS of length minus 1 is 1. So this one. So that's why length become 1. So is it matching? Length of 1 is B and this one is C. Is it matching? Obviously no, it is not matching. So what we will do? Again it will becomes LPS of length minus 1. So length minus 1 is right now 1. Minus 1 it is 0. LPS of 0. LPS of 0 is nothing but 0. So length will be updated by 0. So again it is matching. It is matching. Checking with 0th index, this place and this place, it is matching. No, it is not matching. So that's the reason when, but the thing, it is not matching, come else condition. But here right now length is 0. So that means I will put LPS of I equals to 0 and increment my I. So LPS of I will put 0 and increment I. So right now my length becomes 0. This is why my length becomes 0. So hope you understand why I doing that length of minus 1. Because if I simply do length equals to length minus 1, that means what? I will check whenever length is 2. The length is 2 means what? Length is 2. But I am checking not length is 2. I am checking when length is 2 occur for this space. For this space length becomes 2 or not, because for 3 it is not for 3 it is getting 3, but 4 it is not getting. For that means 3 it is also not matching. Line 3 it is not matching, so this place is not matching, so this is not matching with this. So that means I have to check length minus 1 by an LPS. Sorry, LPS of length minus 1. So length minus 1 becomes 2, and 2 index, this is coming giving me 1. So I have to length becomes 1. So that time this index, this length becomes index. So again I have to check same index. So length, target of length of status string. This is how we are checking in about this length. So after that, what should we do? We should do I becomes at the 6 index. Now length is 0. Now see, it is matching again. So whenever it is matching, length will be updated by 1, and same length will be updated in the LPS section, and I will be incremented by 1. Now again, you see this is matching. So again, length updated by 2, same thing will updated by here, and again my I will be updated. Again matching, length becomes 3, and I will be updated by 3. I will update by 3, and after that my I will be incremented from here to here. Last. This is also matching with the length of 3 index. So that time it will updated as 4. Same thing will be updated as 4, and I goes to the next place. So it is out of it. So this is how we can create our LPS array. So this is how we can create our LPS array. Now let's see how could we use our KMP algorithm. So LPS is one building block of the KMP. Without LPS, we cannot build our build our KMP algorithm. Now see, now KMP will be easy. Okay. So let's take the example. Let's say our target string is let's say not target, our text string is, and target string also build it. Let's say ABD, our previous example. So text string is ABC, then AB 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 D, sorry, AB, then AB and D. So let's say this is our text string, this is our target string. Let's say also AA also present. So if I put the indexing here, indexing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. And this is 0, 1, 2, 3, 4. If I do the LPS of this, what is my LPS of this text string? LPS will be uh, 0, 0, 1, 2, and 0. If you do the algorithm, this is our LPS. Now let's start our KMP algorithm. It's a function KMP algorithm. KMP. So it will be target. Sorry, text is also given. Text is given. Text is given, and target is also given. So simple. We first do what? We will first calculate our size of the text and target. Let's say n equals to text dot length, and m equals to target dot length. Okay, and I need to call one function. So that's why my LPS, I need LPS. LPS will be construct LPS function. I have to call construct LPS. So I will pass the target here, and I will call this function. This will return me the LPS error. Okay. So right now I have to iterate again. So I will start I equals to 0. So I'll do I equals to 0, and also I need j. J is pointing to the 0. So this is I and j, obviously. This is my I and this is my j. Correct. This is my and this is my j. So okay, point j here. This is my j. Obviously these two pointer I need here, the I and j. After that I need a while loop until while my I I is less than n. So I will iterate from this end to this end. Okay. So I will iterate from this end to this end. Okay. So that will I will iterate. So I'll doing the iteration. I'll now what to do. So I starting is 0. If both are same, if both characters are same, if both characters are same, then I will do what? Simply that if text of I equals to target of j, if both are same, then I will simply increment both of them. That's simply what I do usually. I plus plus j plus plus. Okay, simple case, isn't it? So if the problem will arise right now when both are not same, what happens if both are not same? And if both are not same, then I have to check something. So let's see if that case arises or not. So this is done. So else, what is the case we have to do? Else. So else what I have to do? See here. See here what I actually doing. Now here both are same, so that means it will update. I will be updated here, j will come in this place. Again both are same, I will come at here, j will come at this place. Again both are same, I will come here, j will come in this place. Again both are same, so I will come here and j will come here. Now see, this is our stop. Earlier we are doing stopping here, and we after that whenever mismatching happening we are back to the previous case. So right now we will not back to the previous case. What we will do? We will do where? So right now, as I told you, this AB has appeared. This AB has been appeared, and in this AB, this AB is common. So how could I know which place it is common? I will go back to the previous case and I'll check LPS, longest common substring. Sorry, longest common prefix and suffix for this case. So it will get return to the 2. So it will say like I am getting second character, go to the second character. Before that character, it is going to the redirect to the second character. Why second character? Because before 2, so before 2, uh, it will check like this AB. I am checking this case for this character. Is it a part of any longest common prefix or suffix or not? So it is. It says something is there. So it is a part of longest common prefix. Now up to which it is longest common prefix is there. Say it is a part of 2 length of longest common prefix. 2 length of longest common prefix means 0 and 1 is the longest common prefix and it is a part of that. So instead of starting from 0 again, I can starting from second index. Why second index? Because length is 2, 2 length of prefix, right? 2 length means 0 and 1 is booked, so I have to start my j with the start the j with the length, with the previous length. So instead of j is here, so I'll check the previous one is pointing in which place. If it is pointing 0, I'll go to 0th place. If it's pointing different place, I'll point that place. So it is the case, so that's why I know like it is same. So AB is a part of longest common prefix. So AB, which longest common prefix? How many length of prefix? 2 length of prefix. 2 length of prefix means 0 and 1 length of prefix. So I can ignore 0 and 1 length because that is already appeared. So that's why I will jump to the this A, index A, and that is second index. So we'll simply whatever that this J is mentioned, I will simply go back to there. So I will simply go like I'll simply write j equals to j will be my LPS of current j minus 1. So this will be my new j. Okay, so that's why I will writing this one. So okay, so let's see. So j will come at this place. Okay, fine. Okay, let's see the what is the next case. Next case I stays here. So see here. So j will go into j sorry j goes back to this place, this index number 2. index number 2. Okay, fine. J goes to this place. Now again it will loop will continue. Loop will continue. Again it will check whether this place target I, this is nothing but this is both are same or not. If both are not same, again this thing will work. This thing will work. What will happen? It will happen. J will becomes length is what? Length right now. Okay, so length is right now. I removed the length by mistake. Can I get back the length? Let's see. Just, okay, so J not length. So what happens? So J comes in this place. So J goes to J minus 1. LPS of J minus 1. LPS of J is right now was what? Fourth index. So right now J is 4. 4 minus 1 is nothing but 3. And 3 it is pointing to LPS of 3 is nothing but 2. So J will go back to this place. Fine. So it will go back to this position. So J will come and right now this place. So right now again it will compare, it will loop will continue. So in this loop what will happen? So again test of I and length of target of J. Target of J is nothing but A and I is nothing but C. It is not same. So whenever it is not same, again come this place. J becomes J minus 1. J minus 1 is 2 minus 1 is 1. LPS of 1. LPS of 1 is nothing but what? 0. So J will go to the 0th index. J will jump back to the 0th index again. So again J goes there. Okay. So again it will compare this one and this one. Again not same. When it is not same, so why it is jump back? So AB for AB and AB is matching. Okay. So AB and AB is matching. So that's why it come jump to the this AF place, this index. So before that, like target was 2. Before that, like AB is a length of 2. Prefix is same of suffix and with length of 2, so that's why it is indexed to this index. Now it is also not matching, it is also not matching. So that time if it is also not matching, then it should jump to the any other place. When which place is jump, so it will shoot back to the first index, 0th index. So that's why it is pointing to the index J. So right now it is point there. So J minus 1 is 1, and whatever the pointing is, now it will say like whether this part, this previous part is a part of any uh, prefix suffix or not. But you know this is the here no longest count prefix and suffix. That's why it is pointing to 0. So J is pointing to the 0th index, this place 0th index. Okay. So J go to 0th index. Now it will again check like this one, this place 0th index, and it will check again. It is not same. But if I do right now again J minus I, so it will create a problem. Why problem? Problem because see, if it is not equals to 0, then do this one. If it is equals to 0, we can't do anything. If it is not equals to 0, we simply increase the uh, case. So if it is, the condition is if j not equals to 0, then only I can do this step. Then only I can do this step. Otherwise, if it is 0, if j is equals to 0, else what happens? In this case, right now j is pointing to A, 0th index, and I is pointing to the 4th index C. So what is this case? Else, if it is not the case, then I can say nothing is common. So I can simply increase I plus plus. I plus plus. That's all you have to do. All you have to do. And this is the case. Okay. So another condition will come, I will tell you later, but let's do the algorithm first. So I will come to this place, and now again I and j is same or not. If it is same, then so j will come this place. Let me write j here, it will be easy to understand. So let's remove this j and remove this LPS a little bit lower. Okay. So j will come this place. So j, okay, okay, let's remove this one as well. Okay, so I and j are both are same, so j was there, so both are same, so I and j come here. So here also I and j are same, so I comes this way. So both are same, I and j are same, so I will be incremented, j will be incremented, again I will be same, so I will be incremented, j will be incremented, again both are same, I will be incremented and j will be incremented. So write this position. This is the again conflict occurs. So in this place, I and J both are not same. So again, I will check what are the previous cases of same AB, and this AB. These are the match in terms of target. These are the match. So obviously these are the match in this case. That's why J comes in this place. J comes in this place. That means at the very beginning, like before this Jth index or Ith index, this AB is match. So AB is match. Right now, in the AB, is there any common prefix suffix present? Yes, AB is the previous. I will check the previous one. Previous index I will check. Like current JS previous index. Is there previously? Is there any prefix or suffix same or not? If it is same, yes, it is present. Then I will move my pointer in that J index. So I move that J in that index. So I move this J in the second index because previous whatever mentioned here, J will move to the check the previous case. Is the previous whatever the index present in LPS, I will move that case. If it is 0, if let's say instead of 2 it is 0 there. So 0 means what? This AB is not part of any prefix having no prefix or suffix is common. That time my J should start with the 0th index. That is the case. Otherwise it is fine. Okay, fine then. So in that case, I will be there. Okay, so it is the case 0 and I will be here. So what will happen? So I will right now, again it is match now, A and J are same. See, right now it is a matching. So I will increment it, J will also increment. Again I will increment matching, so I will increment, J will increment. Again I will increment because D matching and J comes here. So I have to write one case, extra case here. I have to write one extra case here. Here I have to write if my J equals to my length of target M, then I will return true. Return true means it is present. Return true. Here I am returning true. In case you may need to return something, so and it is a KMP algorithm. That's why I am returning true. I am writing for the KMP case. So return false. Otherwise. So if it is not present, so this is not case. So this is why you can return true if it is present at the end of the loop. If it is not present, I can simply return false. Return false. If the loop ends, that means it is doesn't matter. It doesn't find. So I will return false. It is the case. So because J becomes n, J becomes this size of the target out of index. So size of the target, that means I found my character inside my text. So that's why it is returned to. One case, this is how the algorithm works. So it is not for sure like every time there will be some LPS, it could be 0. That's all distinct characters are present. A, B, C, D kind of that. Let's say A, B, C, D is my target string. So that time LPS will obviously 0, 0, 0, 0. So in that time, so if I have a string like this, if my start string or my text string is like this, text string, let's say A, B, C, let's say then A, B, C, then B, C, then D, like that. If it is my text string, if I do my algorithm, so I start here, J will start here. So both are same, both will be incremented by J, both will increment by J, increment one as J. Both are same, again it will increment, J will be there, I will be here. Again it is same, so it will increment J here and I here. Now it is not the same. So as per my algorithm, J will point back to the coming to the check the previous one, going to check the previous one, and the index LPS index will transfer to the LPS index. So it is pointing 0. So it will J will go back to 0. But the noticeable thing is like I am not going to redirect the I. I am not going to redirect the I. Okay, I will be stay at the same place. I will be there, but I'm just rewriting to the J, but not the I. So for each I am not checking each J. So it is time complexity will be now reduced. What is the time complexity? Now this is the question. So this loop, I loop, is going to ith time from this index to n index it will traverse. So it is obviously big of n. Now you can ask me one thing. Like, see here, I plus plus happen in particular cases. So your I plus plus happen if it is true. In the else condition, it is true. It is I plus plus happen. What if J is now reducing? Sometime you will notice J starting here, then J comes here, then J comes here. So yes, J is backtracking. For some of the J, I is going to be calculated 2 or 3 times, but not for each and every I. Okay, for not for each and every I. So what can be case? J can be traversed from this place to this place. It is possible. Some of the place it can move from this place to this place, this place, this place, this place. It can be possible, but not for each and every I. Okay, so not for each and every I. So it is reduced. So it is somehow reduced to n plus m. So this time complexity is not only n, so it is big of n plus m, because k time it may shift. K time it may shift. It may be n plus, for sure fast loop is big of n time because I is written. So sometime it could be 2k time, or sorry, 2m time. 2m time it is shifting. M is the length of the our target string. So it is k plus n plus k into m. K into m. K is a constant. So it could be 1 time, 2 time, 3 times, but it is not similar to the n time. But k not equals to n for sure, because you can see every time if it is a match, I is incrementing. If it is not a match, J will stay the same place. If it is not the same, if let's say J is the some, let's say some random case, let me give you an example. Let's say some random case. So some random case I can take. Let's say it is A B C D, A B C D, and you know LPS is 000, and our string P Q R S T U V W X Y Z. So if this is the case, my I is here, J is here. If not, if it is not same, what happens? You notice here, if it is not same, it will check if J equals to 0. If J equals to 0, I will be increment. So simply J will not match, but J is 0. Like LPS of J is pointing to 0th index. So I will increment. Again, I will increment. This is how I will increment. J will not change at all. J will not change at all, and I will be increment. So the main thing happens, the main advantage of this algorithm, every, our naive or brute force algorithm, I am pointing back to the I, to the next point, mainly the starting point. Every point of I, actually I am checking with the J, each and every J. So right now I am checking each and every J, maybe not always, maybe some of the cases I have to check every J, but not always. Even though I have to iterate J if there is a pattern. If there is a pattern, then only I have to check in each and every J. So if A is there, then from this pattern, I will directly jump to this place. Correct? So isn't it? So what happens? So let me write the LPS of this as well. LPS of this will be, it is 0, this is 1, this will be, sorry, this will be also 0. After that, this is 0, this is 1, this will be 2, and this will be 3. So if something has happened, so 0, 1, 2, 3, 4 indexing. If some mismatch happens in this place, J will directly jump back to the which place? Jump back to the second index, to this index, because before, what are the LPS stored before character? What is my current J? J is right now here. I have to jump back to the previous character LPS position. Previous character is what? B. His LPS position is to jump back to the second index. So I will jump back to the second index. So this place directly. Okay. If something has happened, again I will jump back to the, if mismatch previous character LPS nothing but 0. So I am going back to the this 0th index. The jumping is not also a linear jump. It is a very too much, like if it is a matching only there, then only I will jump. Otherwise, if there is no match, see here, there is no match. So let's say D is present here. No match, it will directly point 0. So I will instantly jump to the 0th index. So if pattern is present, that time I will jump to that pattern. Not only a single jump, one step jump. It will be a long jump, at least 2-3 step of jump out there. So that's why it is not taking big of k time. So it is taking big of n plus, this is taking big of n plus m time. this loop also taking big O of n plus m time. Okay, so time complexity reduced to n plus m. Okay, so what is the another complexity of what is the time complexity of this this function? Okay, so let's take this function. Here also it is taking to the big of m time. Okay, big of m time it is taking. For same thing happens here. It may take big of 2m, big of 3m, but it is big of m because see, I starting from 0 to 1 to m. Okay. Secondly, it is starting here like I like I is also like length is also going back. But think sometime, see, whenever condition satisfies I plus plus. Whenever condition not satisfied, I do I plus plus when LPS I becomes 0. This becomes 0. Length of thing becomes 0. Whenever it becomes 0, then I'll do I plus plus. Okay. I can do I plus plus at this moment. Fine. So whenever I do I plus plus, then it will again increment. It will again increment. So most of the even though it's jumps will drastically happen. So it's from here to here, here to here. This is the way jumps may happen. Not single jump will happen. Understand? So there's the reason this has a time complexity of big of m. LPS have time complexity of big of m. So big of m. So what is the overall time complexity? Overall time complexity is big of n plus m. N plus m. And space complexity, you are taking on extra space for storing the LPS. This is nothing but big of m. So this is our KMP algorithm. This is how it works. I know this is a very big video, but it is very useful topic. You have to understand the topic. This is a very good algorithm. Normal string comparison takes big of n plus m time, but KMP takes big of normal takes big of n into m time, but KMP takes big of n plus m time. Okay, so for this specific kind of problem, I have to return the exact same place when it is case, right? When it is matching. So in this problem, KMP algorithm looks the same way. This is the KMP algorithm return. So instead of returning here my true or false, so KMP returns true or false. Instead of returning true or false, I will return here what I should return. Mm, my I minus z, and at the end it is not there. I will return -1. Simply I will do this. This case. Hope you understand the process. This algorithm is very important. It could be asked in any exam, any interview. Actually, this is the one of the finest algorithm you should have learned. Okay, so hope you get it. And I guess I did one mistake here. No, fine, not here. Yeah, here is whenever I starting this time. So I was starting with a 0, but it should start with a 1%. Actually, I explaining every time starting with 1 or written 0 here. 1. So apart from that, I guess there is no mistake. But still, if you find any mistake, please let me know. I can rectify that. And if you find any useful information on this topic, also let me know. Then I can also learn. Hope you understand the logic. It is very long and very difficult, I know, but we have to be patient and please do try and take many examples, many different cases. Then you will learn why this algorithm works and why not. Then it will be much clearer than it. And please understand, like don't just issue this algorithm. You have to just you have to understand the intuition why you are doing that, using LPS and this kind of stuff, this jumping. Otherwise, you will after learning this algorithm after 2-3 days you will forget. This is very tough algorithm and easy but tough algorithm, I should say. But if you understand the intuition once, then you will understand the entire thing very clearly. Okay. Okay then. Thank you. Bye bye.